Alright, let's continue. Okay, so let me check. Alright, I've been thinking maybe instead of making this an error, we can just kind of add the null terminator at the end, you know. Now let me see. CPY good. Oh. I think this one, right? The code for strl CPY. Yeah, similar to this, I guess. If the last byte is not null terminated, we just change that to null terminated. So for example, let's say we have this one, right? And C, and then if this is not, if the last one is not null terminated, we just null terminator or null byte, we can just change that to null byte like this. Okay, so let's try that out, which means that maybe something like this. Not really src, because we already copy the source to the destination. Okay, now this 21 not equal. Null terminated. Then one equal. Let me compare that. And this is compile. Okay. Let try changing this. Maybe something like this. Nothing changed. Wait a minute. Again, I forgot. Okay. Oh. And we put okay. Something like this. Symbol does not exist. Okay, let me check. What is going on? Wait. Okay. We are in. Alright. Alright, next. Destination lane. T. Okay. Oh. So we have Lee instead of lab. Disable. Let me check first. Okay. Lee arts. Symbol does not exist. Okay. Well, at least we know that kind of work, but might not be expected, I guess. There's no terminate. But yeah, I mean, so it's the God does not include no. Reference. Okay. Details. No, yes, yes. Fractal. Feels like this. Is this trap? No. Okay. Maybe. Oh, fun. So let's try. Interesting. Disruption. instead of error. Another tutorial. Right, it looks like not apart from null terminate string when using snprintf. So let's try that out, I guess. But in POSIX, snprintf fprintf, okay. Division of n, okay. If n is 0, the size or the total character is 0, nothing shall be written and s may be a null pointer. Otherwise output bytes beyond and first shall be discarded instead of being written to the array. Okay, so kind of similar to our implementation here. Wait. Okay. Kind of similar to our implementation here. This one, right? It's just in this case we are using n instead of destination line. So be discarded instead of being written to the array, and a null byte is written at the end of the bytes to be written into the array. That overlap as a result. Oh, so yeah, maybe we should check the, what is it called, the return value of snprintf. Maybe let me check. Okay, the return value is integer. This is interesting. Even though the size is the return value is integer, even though the size is size t. Let me check. Let me put this in here. This one, okay. Oh, not in this one. STTI, oh, okay. Let me check. Alright. snprintf. Oh, phonetic function. F snprintf underscore internal. Interesting. Why is it integer? Do not write more than size byte. If the output was truncated to this limit, then the return value is the number of characters, excluding the terminating null byte, which would have been written to the final string. A return value of size or more means that output was truncated. Affiliates. The result are undefined if source and destination buffer overlap when calling snprintf. Depending on the version of GCC used and the compiler option employed, such as the above will not produce the expected result. Okay. Fs and printf. Not this one. Then where is it? Leave IOP. It's where can I see this implementation? Not this one. Oh, in this one. lib.io. Okay, let's check. This one, right? F snprintf internal. Okay. use if the max length for the character is size t, why the return value is integer, especially when a return value of size or more means that the output was truncated. Interesting. Hello, Victor, welcome. Well, you can take a look at my the live stream description for the book that I use. It was called With Your Own Lisp.com. This is the book reference for the current project. So you can take a look, or maybe you want to check out another book. What is it called? See Modern Approach. I think this one, but yeah, this can be quite expensive, I guess. A lot of people recommend this book. I usually just browsing, I guess, just using this engine to look things through. Okay, hello family of Sharma, welcome. I am currently trying to check how to handle snprintf if, what is it called? If there is not enough space, it means that the output was truncated. So maybe we can do something like this. What is it? Maybe something like this, but not output. And then if the output more than or equal limit, let me check. Value N, okay. Value N. Limit -1. So Hello, Tornado. Welcome. But yeah, let me try. Let's assume we have this one, right? 3 character, and then have this A, B, C. Basically 3 character without no terminator. snprintf case. What is it? Child. Okay, size the format. Okay. The font size. Okay. Maybe we can do this. String. Wait a minute. Oh, wait. Okay. Look like something like this. Format first and then the rest. The argument. Now, let's print that out. We are using this. We are going to get there. Okay. In GCC, the snprintf got no terminated, so I think that was why we are fine, right? check equal -1 equal this one. Zero, okay. Interesting. Alright, so that means size not equal this one. Okay, and then we replace the last, what is it called? The last character with no terminator, and then now let's check this out. Okay. Right. There's no terminator now. So, maybe not like this. More than or equal size. Maybe something like this. Okay. If the snprintf output equal or more than the provided size, where is it? This one. Return value of size or more means that the output must truncate. Then the provided more than the provided size, then that means return value equal no negative value is returned. snprintf return negative value. Like, what is the case? And snprintf returning negative value. Welcome. The count pass did not. Using underscore. Is it the Microsoft one? Makes me suspicious if it is possible it can return negative values. It means there was an error. Do not try to use error now. Incidentally reset error now. Set enter. So if it is negative value, okay. If the return is negative value, it will return. It means it's an error. Okay. I like use this as if output less than 0, and then that is the case. What error message that I use? My stomach is growling again. Maybe do something like this. got an error. Throw an error. Final line, and then exit. What is it? It's not the same. 52 maybe. Yeah, let's just use 52 as the exit code. Okay. There's a possibility. Okay. That the string is not terminated. Yeah, let's call it that. Oh, maybe that's why they are using integer value, so we can have the negative value. But then again, when we trigger the negative value, okay, let's take a break. Let me go to the toilet first Be right back. Okay. But yeah, how can we trigger the negative value of printf as snprintf? This is the Microsoft one. Preventing buffer overflow. And printf size of all pad more than pad max. Needed. Oh, that's just a nice. Now let's call it SNP out instead. We needed more than only causes of, okay, bed too long. Number with commas. What population? Check return value, truncation, let the return equals or exit buffer size. Wait a minute. Rather than using this, I think we already got file name and line number, right? So might as well use that instead of this macro. file name and number, something like this. Let me check if it is compiled. Okay. Limit is unsigned in. That is hard. Okay. Let me check. Okay, the return value is unsigned in. I mean, I could guess the result, right? But is it the right move? Unsigned in with sign in. Convert to unsigned in before the comparison. As well as for the purpose of performing subtraction. Maximal possible unsigned in. You know what? If that is the case, maybe we should swap this. So we check if there is an error, right? And then when there is, and then if we are sure, no, what is it called? No negative value, and then we compare that with the limit. Let's check. It is still okay. I mean, is this fine? We already check if SNP out negative or not, right? So if it is not negative, then we compare that with the limit here. I assume this is kind of fine, maybe. We will see. I'm kind of curious, and we like do this. I don't think we can. Okay. I mean, you know, there is this like V type, something like this, right? Looks like it only appear only possible with the number, I guess. Interesting. Let me check. We are in the error, right? Okay. I mean, okay. 69.0. Okay. And again. 69. All right. How do I give a comment here? Okay. There is an error. Over magic number. What magic number is it? Oh, okay. Is it a feature? Maybe. Let me think. let's call it a feature case. And is it called? Get that. Error with snprintf. We only use snprintf in this one, right? Okay. Looks like. Hello, welcome. Echo sound. What is snprintf used for? Oh, it is to, what is it called? To copy some string to another memory, something like that. So wait a minute. So let's say we have a memory for the error, right? And we want to copy the message with the format fmt. Maybe I can show you this. Okay. We have this, what is it called? We have this memory called A, and then we have the size. It is 3 in here, right? And we have this format. I mean, we can also do this, right? Let me do this. Okay. Now this means that we want to copy the character in B to A with the specific size and also specific format. This is the string format specifier. So we get this one into this, if I understand correctly, and then we add this one. But the interesting part is that there's a possibility the size we provide is not what is it called, less than the actual, what is it, the actual message that we want to save. For example, in this one the size is 3, right? But in this one we kind of doing something like this. It is more than 3 characters, right? So the value is truncated. We are not getting all of this. And well, I add some kind of checking, right? If the output is more than the size, which means we have truncated value, and that means that we don't have a null terminator, which is what is it called? A signature of string in C programming language, and that can be dangerous if the string does not contain null terminator. Oh, sorry, it should be A. Why is it B? It should be A. Okay. So let me run this again. Okay, at least the result is the same. So that's basically what snprintf for. Let me, maybe we can find an official description. No, not this one. Yeah, basically snprintf is writing the output with some kind of format to other data storage, like memory, like dynamic memory, or maybe a variable, right? So yeah, it's like copying some kind of value. And this can make me interesting, can make me curious. If there is no terminator, right, what this will look like? Let me check. Okay. So yeah, anyway, we are exiting the size. So that is why there is some kind of truncate, like we didn't really get all of this value. And yeah, I'm trying to handle that out. Okay, looks like the sort of SN truncated, and in some documentation, truncated value might not have no terminator. No terminator. Have no terminator. So in these changes, we try to handle try to add the no terminator manually when the put of truncated even know. What is it called? Output of snprintf truncate. Also check if there's an error when using snprintf. Currently still not sure how to trigger an so we have not that yet. Let's see how it goes. Okay. Sample handle snprintf. Truncated value. I mean, when snprintf truncate like that, and let me do some replacing here. Okay, we commit the playground first and then the handling stuff. Right, this one. Alright. Okay. Alright. I am still in break period. Okay, let's. I really want to read this. Okay. Maybe let's read together, I guess. Let me copy this in the chat. This summer, I'm working on Rust full time. And again, I will work amongst other things on a memory model. Okay. However, before I can talk about the ideas I have for this year, I have to finally take the time and dispel the myth that pointers are simple. They are just integers. Okay. But part of this statement are false. At least in the language with unsafe feature. Like Rust or C. Pointers are neither simple nor just integer. Okay. Alright, let's check that out. I also wanted to find a piece of the memory model that has to be fixed before we can even talk about some of the more complex part. Just what is the data that is stored in the memory? Right, this is kind of an interesting question that I'm also curious, what is the data that is stored in the memory? It is organized in bytes. The minimal addressable unit and the smallest piece that can be accessed. Is it really the smallest piece though? I mean, there is bit, right? Is byte really the smallest piece that can be accessed? Oh, and this on most platform. Okay. I mean the return of size of, if I remember correctly, or maybe char bit, this one, right? Number of bits in type char. And a lot of people say that char bit is always 1 byte, something like that. And yes, there is a possibility that on another system 1 byte might not be 8 bit. That is something to keep in mind. See, at least on most platforms, right? But what are the possible value of a byte? Again, it turns out it is just an 8-bit integer. Okay, does not actually work as the answer. So this is not the answer. Okay. I hope that by the end of this post you will agree with me on both of this statement. Let's see. What is the problem with pointers are just integer? Let us consider the following example. I'm using C++ code here mostly because writing unsafe code is easier in C++ than in Rust. Unsafe code is where this problem really shows up. C has the semishuttle. Okay. Alright. Oh, we are using the auto keyword. Yeah, this is one of the difference, I guess, between C and C++. The auto keyword in C is not really inference to the assignment like this. So that is something to keep in mind. It would be beneficial to be able to optimize the final read. Just return. Okay. it's been good. It's been good lately, so yeah. Regularly perform such optimization as they are crucial for generating high quality assembly. The justification for this optimization is that to xptr, which point to x cannot change y. R points to x in this one, I think, and then we change this, right? That's not really affecting y. Oh, okay. So we kind of skipping this one, if I understand correctly. However, given how low level a language C++ is, we can actually break this assumption by setting I to y negative x the same. Okay, this is the what is it called? The pointer arithmetic, right? This one is like the offset of the pointer. So we are kind of dereferencing x with the index I and then get those memory address after dereferencing. It is kind of similar to this, the pointer arithmetic. However, given okay, this means that we are actually writing 23. Oh, wait a minute. Of course, that does not stop C++ compiler from doing this optimization. To allow this, the standard declares our code to have undefined behavior. Okay. First of all, it is not allowed to perform pointer arithmetic that goes beyond the end of the array it started in. Our program value violates this rule. Is outside of x, so this is undefined behavior. What is the new keyword in C++? I'm not really sure. If we try to make this in C, is it something like this? Maybe. Y042 and I, okay. XPTR. In XPTR. Something like that. Okay. Let's try to keep the position as close as possible. Okay. XPTR and then 23 return y 0. Maybe something like this. In C. Yeah, I'm not really sure what this means in C++. Okay, let's continue this one. Just the computation of is already undefined behavior. We don't even get to the part where we want to use this pointer. Okay, but we are not done yet. This rule has a special exception that we can exploit to our advantage. If the arithmetic ends up computing a pointer just past the end of an allocation, that computation is fine. This exception is necessary to permit computing the end. Okay. One past the end. Okay, wait a minute. Right, one past the end. Because we are starting from 0, right? So the maximum is 7. Oh, okay. Not like this one. Kind of wrong. Maybe something like this. The array, right? One past the end. Yeah, this is the offset from the 0 index. So if this is 8, I assume the, what is it called? The size of the array is 8, then the maximum should be 7. This is index out of bounds in some programming language. One past the end. If I understand correctly, XPTR equal like this one. Okay. The memory address equal Y. I mean, we can just use Y instead of like this, because we are accessing the index 0. So if the memory address in XPTR is the same as Y, then we put the value 23. Oh, wait a minute. This is kind of interesting. You know what? I kind of want to try that out. Let me check. Let's try using it too. Okay. In X, like this, then Y, xptr equal, what is it again, x plus 8. I want to check the memory address. Okay, it is the same. Now that is interesting. So it is contiguous, I guess. Right. So I can change this to be something like this. Oh, sorry. Okay, which means I can do something like this, and it should be the same. Right. Little bit of information. Okay, right. You want past the n. So if this is the same, if the memory address is the same, then we change the value from this memory address, which is basically we are also changing the value for y at index 0 to 23, so this become 23. Well, let's find out. If xptr equal y, xptr, let's just use 69, right? Print okay, integer right, y0. We can, let me just explain that after this. Okay, we are changing to 69. We can also use the reference character for the index 0 like this. Right, it's the same. And if we want to use the offset, we can do something like this. But yeah, we don't have the value yet. So this one is actually, what is it called? Something like this one. See, we are dereferencing the offset offset from the Y memory address. It is index 1. Okay. Okay. Now imagine that X and Y have been allocated right next to each other, with Y having the higher address. Then XPT are actually points right at the beginning of Y. And welcome in IX spiral. Okay. Well, I hope you get your work done. I mean, yeah, I'm still learning this one. Okay. Then XPTR actually points right at the beginning of Y. The conditional is true and the right happens. Still, there is no undefined behavior to out of bounds pointer arithmetic. Oh, wait. Now imagine that X and Y have been allocated right next to each other, with Y having the higher address. Oh, like we are swapping that right at the beginning of. Wait, what the higher address? Sorry. Well, isn't this scenario? Then XPT are actually points right at the beginning of Y. Right. The conditional is true and the right happens. Right, this one. We are replacing the value of the index 0 Y. Okay. Still there is no undefined behavior due to out of bounds pointer arithmetic. Okay, I mean, in this case, maybe we can say that we are kind of lucky. I mean, if Y is not next to the end of X memory, right? Then this can become a time bomb. We are trying to access unallocated memory. Something like that. They seem to break the optimization. Oh, okay. However, the C++ standard has another trick up its sleeve to help compiler writers. Don't forget to drink water. Allow us to use. Okay. According to what standard says, when someone pass the last element of an object, right? Because this is an offset and we start from 0, so the maximum should be 7. You can think of it like this: 0, 1, 2, 3, 4. Maybe something like this. Okay. Right. You know what? Maybe okay. Something like this. 0 until 7. Okay. Does not point at an actual element of another object even if they have the same address. Does not point actual element of another object even if they have the same address. Oh, is this only in C++? I am not sure. At least that is the common interpretation of the standard based on which LLVM optimized this code. The key point here is that just because xptrn, what is it called? %y index 0, just because the memory address on xptrn index 0y points to the same address does not make them the same pointer. Oh, does not make them the same pointer. They cannot be used interchangeably. Yeah, there is no guarantee that it is always the same, if I understand correctly. The index y points to the first element of y, x underscore ptr points to the end of x. If we replace this one by this one, we change the meaning of the program, even though the two pointers have been tested for equality. Yes, the meaning of the program. Okay. This is worth repeating. Just because the pointer points to the same address does not mean they are equal and can be used interchangeably. If this sounds subtle, it is. Let me go to the toilet for a bit. Be right back. If this sounds subtle, it is. In fact, this still causes miscompilation. Okay, not that one. Okay, this still causes miscompilation input and GCC. Okay. Also notice that this one past the end roll is not the only part of C or C++ where this effect can be witnessed. Another example is the restrict keyword in C, which can be used to express that pointer to not alias. Pointer to not alias. Oh. Calling test trigger undefined behavior because the to access info must not alias. Okay. Okay. But will we get an error, a compile error, for example? Info change the meaning of the program such that it no longer has replacing this one info. It no longer has undefined behavior. Okay, it become undefined as far as I understand because we are using the same memory address. So the result is kind of ambiguous. First we change this one, right? Which because we have the same memory address, we are basically changing X and Y. And then if it is the same, we are changing that again to 23. So if I understand correctly, most likely this become 23 in this scenario. But yeah, again, this is undefined behavior. Some compiler make two different things. Even though X and Y have the same address, they cannot be used interchangeably. Pointer are definitely not integer. Okay. A simple pointer model. So what is a pointer? I don't know the full answer to this. Okay, in fact this is an open area of research. Right. Open area of research. One important point to stress here is that we are just looking for an abstract model of the pointer. Of course, on the actual machine, pointers are integer. But the actual machine also does not do the kind of optimization that modern C++ compiler do. So it can get away with that if we wrote the above program in assembly. There would be no undefined behavior and no optimization. C++ and Rust employ a more high-level view of memory and pointers restricting the programmer for the benefit of optimization. When formally describing what the programmer may and may not do in this language, as we have seen, the model of pointer as integers fall apart, so we have to look for something else. Okay. This is another example of using virtual machine that is different from the real machine for specification purpose. Wait. Okay. A simple proposal. In fact, this is the model of pointer used in COMSOLT. Merely implement. What is COMSOLT? Oh, it's a document, huh? I'm not gonna download that. Oh, an interpreter for RAS. Mid-level intermediate representation. And define behavior detection tool for RAS. Let me copy this in chat in case anyone curious. Yeah, I haven't learned RAS yet, so I'm not really sure. Pointer is a pair of some kind of ID uniquely identifying the allocation and an offset into the allocation. If we define this in RAS, we may call it. Okay. Alright. Adding or subtracting an integer to or from a pointer just act on the offset. Right, this is what we've been talking about. Adding or subtracting an integer to or from a pointer. Maybe we can subtract from a pointer. I haven't tried that yet. Let me check. How do we check that? Maybe something like this. Y PTR Y -1. So we are kind of trying to access the end of x. This one. The last element of X array. Let's call this 42, for example. And then negative 1. Let me check. Okay. We can add or subtract. But yeah, the subtraction can be undefined behavior, you know, or maybe unexpected is the right word. Yeah, this is index out of bounds. But it is possible if you really want to, I guess. A pointer just act on the offset from 0. Again, we are starting from 0 index, and can thus never leave the allocation. Subtracting a pointer from another is only allowed when both points to the same allocation. Allocation, okay. It turns out, and Mary shows, that this model can get us very far. We always remember which allocation a pointer points to. We always remember which allocation a pointer points to. So we can differentiate a pointer one past the end of one allocation from a pointer to the beginning of another allocation. So Miri can detect that our second example is undefined behavior. Okay, the offset. The model falls apart. Okay. In this model, pointers are not integer, but they are at least simple. However, this simple model starts to fall apart. You consider pointer integer case. In Miri, casting a pointer to an integer does not actually do anything. We now just have an integer variable. Its type says it is an integer whose value is a pointer. An initialize memory. Okay, I will continue this off stream, I guess. And I think, what is it called? I think this might be the end of this series. I want to go into the next learning material, because you could say it is this one. Wait. Operating system 3 easy piece. So maybe on the next live stream I will check this out. Let me copy this in the chat, because my goal is to learn system programming, right? So understanding all of this concept is kind of important for me. So yeah, Thank you for watching and see you next time. Bye bye.